Good morning all, this is Dr. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss programs on string manipulation instructions in 8086 microprocessor under the course Microprocessors and Microcontrollers. So the slides are prepared by referring the textbook Advanced Microprocessors and Peripherals by IARE and Burchandi, publication Tata McGraw-Hill Education. First we'll see write a program to insert a byte in a string. So here we have a string which is a collection of multiple data. We want to insert some string element into this. So here the source string will be kept in one memory location in the data segment. The element which we want to load, that we are going to be copying into another memory location. Then we are going to insert into the string. First, move SI, 2000H, where we are going to have the string which will have the offset value is 2000. This we are going to load into SI register. Next, we are going to have the data in the 3000H location, some ABC pattern. This we are going to compare with the string which is existing. Once it is existing, we are going to copy the new data. So first move SI, 2000H, which is point to the source string. The string which we want to compare, that we are going to load into the DA register. Which string we want to load, that we are going to load in 3000H location. The 5000H location will contain the data where we are going to have some comparison. Whenever these two data, the ABC, if it is existing, then the data which is present in the 3000H, this we are going to be insert. So this data with which we want to search, that we are going to be loaded into 5000. Here the length of the string we are writing as 5 elements are there. We are assuming the string is consist of only 5 elements. And here we want to process the string from 2000 location to the higher order location. So we have to clear the direction flag. For clearing the direction flag, we use CLD instruction. If you want to process from S5 to S1, then we have to load the address of S5 into SI, then we have to set this. So as of now, in this problem, we are going to start the string at a 2000H location. The data which we want to compare, first the string data we are going to load into AL register. The string which you are having at 5000H location, this will be loaded into AL memory location, will be compared with the AL register. If these two data are equal, then we are going to insert the data. Suppose if S1 is not equivalent to ABC, so in the 3000 location, we are going to load S1 data. Let us assume somewhere here I have ABC after S2. S3 is ABC. Next, we will compare S2 with ABC. As these two are not equal, S2 will be more. Next, when you are comparing the third data, when these two data are equal, then we are going to insert new data. So compare AL, BX. That is, with the required string, we are going to compare the source string. If these two are equal, then go to loop 2. Else, copy the data from 2000 location to 3000 location. So for that, we have move SB. Here, how many times we are copying is only one data, because after comparing each and every data, if they are not equal, we are going to move into the destination location. If they are equal, we have to insert the new data. Next, we go for second data. So this will be fetched 5 number of times. The load count which are specified in the CX register, that many times the loop 1 will be executed. Whenever this comparison of the source string is same as that of the pattern which you are going to store at 5000 location, if these two are same, then we are moving to loop 2, where we have at loop 2, first the data will be moved ABC. Next, in the 7000H, whatever the new data is there, that will be copied into the memory location. So here I have S1, S2, later I have ABC, then S3, this is S3, S4 and S5. So 5 data we are having. The pattern which we are going to check is ABC. So this is the source string and this one is the destination or target. So first S1 will be compared with ABC. If these two are not equal, S1 will be copied. S2 compare with ABC. If these two are not equal, copy this. If third data, which is S3 is equivalent to ABC, as these two data are equal, first we will copy the S3 data which is equivalent to ABC. Next, we are going to be load the data which is at 7000H. This is 3000. The source string is at 2000. 7000H, here we have the new data. The new data will be copied. After that, the remaining data we can copy S4 and S5. So move SB, first the data will be copied ABC. Next we are going to fetch the new data which is at 7000 location. So that address we are going to be loaded into BX register. From that memory location, the data will be copied into AL. This data we are going to be loaded into the target location, which is nothing but destination, that is at 3000 some X location. Next, we have to proceed for the next memory location. So for that, go for incrementing DI. As one data we are compared, decrement CH. Then repeat move SB. Later on, the remaining memory locations it is going to be copied. Then we can stop the program by using int3h. The next program is write an ALP to delete a byte in a string. This is the reverse process of the inserting. First, we will take the source string. We will take some pattern. If these two are this pattern ABC, if it is existing in the source string, delete that and the remaining elements you copy into the destination. The source string will be pointed at a 2000 location. So we are going to load the address into SI register by using the instruction move SI, 2000H. Then the target location which is at 3000, that we are going to be loaded into DI register by using move DI, 3000H. The pattern where we are having that we are going to be loaded into move BX, 5000H. So the pattern which we are going to search and delete, that we are going to be loaded in the 5000 location. The source string, how many elements it is consist, that we are going to be loaded into CX register. As we want to process from lower address to higher address, clear the direction flag by using CLD. Fetch the data of the source string into AL by using move AL, the source string address is loaded into SI register. So we can refer the memory location in direct manner through the index register SI by placing square braces SI. Now AL will have the source data. This we are going to compare with the pattern which is at 5000 location. This 5000 we are going to be loaded into BX register. So compare AL, BX. If the source string which is in AL, if it is equivalent to the data which is at 5000H memory location, the address is in BX register. If these two are equal, then the jet flag will be 1, else the jet flag is equivalent to 0. So when these two are equal, go to loop 2 Otherwise, move SB. Copy the data into the target location. Then go to L1. So this will be repeated until Cx is equivalent to 0. Once all the data is copied, we have to terminate the program. So for that, you'll write jump L3, where L3 will have terminating program. So when these two data are equal, then we are jumping to L2. At L2, in the source string, whenever I have the ABC string after S1 and S2, later we have S4 and S5. So S1 will be copied, S2 will be copied, S3 will not be copied, S4, S5 will be copied. So now if you observe, the number of memory locations will be reduced here. So for that purpose, we go for incrementing the DI as well as decrement the CX. So increment SI for pointing to the next memory location, decrement CX, repeat move SB. So continuously the remaining elements will be copied. Then we will terminate the program by using int03h. If we are writing in assemblers, then we have to include the assembler directives also. Like assume CS colon code, DS colon data. We have to define data segments and code segment. So this is directed to work on the 8086 master. We are using int03h. Next program is write an ALP to move block of data from one memory location to another memory location. So here we have the source string, which is consist of some number of string elements. This we want to copy to the target location. As we can't copy directly moving one memory location to another memory location, but string manipulation instructions, we can have memory to memory transfer by using string manipulation instruction. The source string, which is at a 2000H, that will be loaded into SI register by using the instruction move SI, 2000H. The target string location, which is 3000, that we are going to be loaded into DA register by using the instruction move DA, 3000H. Next, how many data we are having in the source string, that we are going to be load the count into CX register by using the instruction move CX, 0008H. For moving the data from the source to destination, we use move SB. As we want to move multiple data, we will proceed this one with repeat. So this move SB will be repeated until CX is equivalent to 0. So here no need of any explicit instruction, because REP, once it is executed, it will decrement and again jump. So the equivalent instruction is move the data from the source to destination. Next, decrement CX. Then go to L1 where I will place it. So these three instructions we can replace with the using move SB with REP prefix. If REP is not there, only one data will be copied. As we want to copy 8 data from the source to destination, we will prefix this one with REP. Then we can terminate the program by generating the software interrupt, that is int03h. Next, write an ALP program to search a number or a character from a string. So here we want to compare whether the given pattern is existing in the string or not. So how many elements we are having in string, that we are going to be loaded into CX register. Clear AX register, load the source string, which is at a 2000, the address we are going to be loaded into SI register by using the instruction move SI, 2000H. The string which we want to search, that we are going to be loaded into a BX register by using the instruction move BX, 3000H. The source data will be copied into AL register by using move AL, in square braces SI. This AL data, which is the source string, will be compared with the pattern which is existing at a location 3000H. So by using the compare AL, in square braces BX. If these two data are equal, that is, if the source data is equals to the pattern which is in the memory location that is pointed by BX register, then jet flag will be 1, else the jet flag is equivalent to 0. So when jet flag is equivalent to 1, go to loop 2, else increment Si for pointing to the next memory location. As one data we have copied, decrement CL, or we can write decrement CX. However, here the count is only 8-bit. So you can go for decrement CL or decrement CX. If it is not equal, go to loop 1. So this loop 1 will be iterated if no string pattern which we are having, if it is not present in middle, so it is going to execute for 4 number of times. That is the count which was specified in CX register. When these two data are equal, then we will come to loop 2, where loop 2 it will decrement, then 0 1 indicating the string is found, then we can develop the program. So here decrement JNZL1, move AH is equivalent to 0 0 and jump to loop. So when string is not found, 0 0 will be copied. When string is found, 0 will be copied into AH register. Next, reverse a given string. Write an ALP to reverse a given string. So here we have the source string. Whatever the string elements we are having, S1, S2, S3, S4, S5, we have to reverse that one in the destination location, where we are going to get S1, S2, S3, S4 and S5. The source string we are going to be load into the SI register with a 2000. The target location, which is at 3000, will be loaded into DI register by using move DI, 3000 location. Assume the string is consist of 8 elements, so we are going to be load the count into CX register by using the instruction move CX, 0008H. As we want to point to the last memory location, so this is source and this one is a destination. Whatever the first data which is having a address is 2000, that we are going to be load into the last location. For fetching that, we are going to add SI, 07H. Otherwise, the second way is we can point to the how many elements we have here, 8 elements SI. So the last address is 2007. This will be loaded into by adding SI with 07. Then we are going to copy S8 first. Right? Two ways we can do. The source string, which is 2007 location, SI data will be copied into AL. This AL contents will be copied into the 3000 location. So as one data we have copied, as we are progressing this source string from higher address to lower address, decrement SI. Whereas the target location, we are going to point from lower address to higher address, so increment a DA. For each transaction, decrement the count which you have specified in CX. If CX is non-zero, then here, if CX is non-zero, then the jet flag is equivalent to 0, else jet flag is equivalent to 1. So what is jet flag is equivalent to 0 indicates string is not completed. String is. What is jet flag is equivalent to 1 indicates all the data is copied. Copied or moved or reversed. Anything. Okay. So till that point, we are going to be loop in the up. Once all the data is copied in the reverse manner, for terminating the program by using int03H. So this up instruction will be, up loop will be executed depending upon the count we are having in CX register. Depending on count in CX register. So thank you. In this session, we have discussed the programs related to string manipulation instructions, like copying the data from one memory location to another memory location, inserting a string, deleting a string, or search for a string and reverse a string. These are the various programs which we have discussed. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.